We are going through exercise 20b, and in this video I'll be answering question 4b. So we have to find the values for x for which the gradient of y equals x to the half is greater than the gradient of y equals x to the third. So it's going to be a similar process to what we did in part A, just a little bit different and a bit more trickier. So that's exciting. So let's come down here and let's see if we can do it. The first word we really need to take note of is the fact that we're dealing with gradient this time. We're dealing with the gradient of both of these functions. So let's begin by finding the gradient of them. So what is the gradient of y equals x to the half? Well, that's simply just the derivative of it. So I'm going to differentiate this, and I'm going to be left with a half x to the negative 1 over 2. And then I'm also going to differentiate this one as well. So that's going to be dy dx is equal to 1/3 x, and then I'm going to reduce 1/3 by 1, so it's going to be negative 2/3, just like that. So just to make sure that we're all on the same page here, I'm going to color code this one blue. So this one is my blue one here, and let me color code the other one green, just so we know what we're looking at here. Okay, so we've got blue and green. Now, the question says we need to find when our blue one is greater than our green one. So that means, when is this one greater than this one? So for which x values is this one greater than that one? So let's begin by simply writing it out like such. So I'm going to say this is x negative 1 over 2 over 2. When is this greater than x negative 2 over 3 over 3. So I've simply moved that x up into the numerator because I prefer it that way. Now, like our past problem, part A, I dislike it when I'm dealing with these rational indices. So to get rid of them, what I'm going to do is I'm going to raise each side by the power of 6. So that's not going to change any proportions of anything because I'm doing the same thing to both sides, but it is going to mean I don't have to deal with these power fractions anymore because I dislike them. So what this is going to look like now is x negative 6 on 2 over 2 to the 6 is greater than x negative 12 on 3 over 3 to the 6. Having done that now, I know that negative 6 over 2 is simply going to be x negative 3 over 2 to the 6 is going to be 64. This is going to be greater than x negative 12 on 3 is going to be negative 4, and this is going to be over 3 to the 6 is 729. 729. Perfect. Now, I think getting to this stage is probably the easiest part of the question. Getting to this isn't too tricky. The arithmetic now that follows, you could go about it in so many different ways. I'm going to show you what I think is the most straightforward way to do it. Maybe not the most elegant way, but the most straightforward way to solve this. What I'm going to do is I'm going to multiply both sides by 729, and I'm going to multiply this side by 729. By doing that, this and this are going to cancel. I'm also going to times this side by 64, and I'm going to times this side by 64. By doing that, this will cancel with this, and now what I'm going to be left with on my left hand side is this 729 times this, so 729 x to the negative third is greater than, and I've just got, because these cancel, just the 64 here, so 64 x to the negative 4. Perfect. The next thing that I want to do is get all my x's to one side. Now, when I'm dealing with negative indices, it's kind of hard to see what you have to do here. So what I would always recommend is, if you're unsure about what to do and you've got negative indices, just bring them down into your denominator and the world will start making sense again. So if you bring them down, as soon as they're down here, you can see I can just use this tactic again, this technique again, to get everything to one side basically. So that means what I'm going to do is I'm going to times this side by x to the 4, and I'm going to times this side by x to the 4. And actually, that's where I'm going to stop, just there. So that will cancel with that. And that means on this side now, I'm going to get 729 x to the 4 over x to the 3 is greater than 64. Now, once I'm in this position, it's quite clear that this will cancel with this, leaving me with just x there. So I'm going to get 729x is greater than 64, I now am going to divide both sides by 729. I'm going to divide both sides by 729, and I should have done that in a different color. Oh, it's too late now. That will cancel with that. So that means I'm going to get x is greater than 64 over 729. And if you wanted to write it in the same way that part A had it, it would be something like this, because you're saying these are your x values. So you can say x dot dot, just like that, if you wanted to be really fancy. But what the moral of the story is that this right here is your answer. That is your answer. So if we were to go back and look at all that working and just kind of reflect on what we're saying here, what we're saying is that when x is greater than 64 over 729 is for when this gradient is greater than this gradient. And if I was to just prove this to you by looking at Desmos for a moment, so I simply found the derivatives of both of these, and you can see the place in which they intercept is 0.88. And if you go into your calculator and you go 64 over 729, you'll get 0.88. And as you can see, my red line is greater than my blue line from this point forward. So when x is greater than this value right there. Okay, hopefully all that made sense. And yeah, bit of a tricky question. Tricky more or less just because of the arithmetic that's involved in it. But hopefully now for A and B makes sense from exercise 20B. I'll see you in the next video.